So in quadratic equation, these are very short answer type questions. So question 1 is, state whether the following quadratic equations have two distinct real roots and then justify your answer. Now they are saying two distinct real roots. So first of all, we should discuss if the quadratic equation is ax square plus bx plus c equals 0, and we know that the discriminant equals to b square minus 4ac. So the nature of roots depends upon this discriminant, that if this d is greater than 0, then the roots are real and distinct. If d equals 0, then the roots are real and equal. And if d is less than 0, then the roots are not real, or you can say no real roots or imaginary roots, or this is imaginary roots. So in this question, we have to check about the two distinct real roots. Distinct real roots means when the discriminant is greater than 0. Starting with question number 1. This is x square minus 3x plus 4 equals 0. So now comparing it with the standard equation of quadratics, which is ax square plus bx plus c, we get for this ax square plus bx plus c equals 0. Now compare this. So we get a equals 1, b equals minus 3, and c equals 4. So applying the formula, d is b square minus 4ac. b square minus 4ac. So b square is minus 3 whole square minus 4 into 1, and the c is 4. So this will be 9. This will be 9. Minus 4 into 4 is 16. 9 minus 16 is minus 7, which is less than 0. Minus 7, which is less than 0. So here you see there are no real roots, or you can say the roots are imaginary. Now the second part. They have given 2x square plus x minus 1 equals 0. So writing our second part, which was 2x square plus x minus 1 equals 0. Now again comparing it with the standard equation, ax square plus bx plus c equals 0. Now we get a as 2, b is 1 and c is minus 1. Now applying the formula, d equals b square minus 4ac. d equals b square minus 4ac. So we get 1 square minus 4 into 2 into minus 1. 2 into minus 1. So actually that gives 1. See, this is minus will become actually plus. 4 2s are 8. So this is plus 8. So 1 plus 8. This is equals 9, which is greater than 0. So hence discriminant is greater than 0. Hence it has two distinct real roots. So this equation has two distinct real roots. So the roots are real and distinct. Okay, now coming on to the third one. Next one, which is the third one. So two distinct real roots, yeah. So see, this is two distinct real roots. We have to find two distinct real roots in which d is greater than 0. Now for the third one, this is 2x square minus 6x plus 9 by 2 equals 0. So writing it over here. So writing it over here, our third is 2x square minus 6x, 2x square minus 6x plus 9 by 2 equals 0. Now, on comparing it with the standard equation ax square plus bx plus c equals 0, we get a equals 2, b equals minus 6 and c equals 9 by 2. Now d equals b square minus 4ac. Applying the formula, b is actually minus 6, so this will be minus 6 whole square minus 4, a is 2 and c is 9 by 2. C is 9 by 2. So minus 6 whole square is actually 36. Square minus will be positive 36. Minus 2 and 2 will get cancelled. Now 4 9 is 36. So this is equal to 0. That means the discriminant is 0. So the roots are, so in this case the roots are real and equal. So you have real and equal roots. Now coming on to our next question, which is question 4. Not for the fourth part, which is 3x square minus 4x plus 1 equals 0. 3x square minus 4x plus 1 equals 0. Now solving this. Now let's write it over here. Our fourth part of the first question is, 3x square minus 4x plus 1 minus 4x plus 1 equals 0. Now again comparing it with the general equation actually, which is ax square plus bx plus c equals 0. So we get a equals 3, b is minus 4, a equals 3, b is minus 4 and c equals 1. So the discriminant d is b square minus 4ac. Minus 4ac. Now substituting the value, this will be minus 4 whole square minus 4 into 3 into 1. So now minus 4 whole square will be 16 minus this is 12, which is 4, which is greater than 0. Hence this 4 is greater than 0 actually. So the roots are real and distinct. So we will have real and distinct roots. Now on to the next part, which is the fifth part. Fifth part is given as x plus 4 whole square minus 8x equals 0. Oh, sorry for this. So writing the fifth part over here. As the fifth part. So this is given as x plus 4 whole square minus 8x equals 0. Minus 8x equals 0. Now over here, applying the identity a plus b whole square. So this will be x square plus twice of ab, which will be 2 into 4 into x, 8x plus 16, because 4 is 16 minus 8x equals 0. So we see that 8x will get cancelled. So x square plus 16 equals 0. So this equation reduces to x square plus 16 equals 0. Now we can write this equation, because we know that the coefficient of x is 0. So we can write this equation as x square plus x into 0 plus 16 equals 0, because here the coefficient of x was 0. So now on comparing with ax square plus bx plus c equals 0, we get a as 1, b as 0, c as 16. A as 1, b equals 0 and c b equals 0, and then c will be 16. So now applying the formula, d equals to b square minus 4ac. So what is b? B is actually 0 over here. So writing here 0, 0 square will be 0, minus 4 into 1 into 16. So this 0 minus 64, that becomes actually minus 64, which is less than 0. Hence the d is less than 0, hence there is no real roots. So the roots are imaginary. Now the next part. Next part is the sixth one. So it is given x minus root 2 whole square minus root 2x plus 1 equals 0. So, oh, again sorry for this. Now writing it the sixth part over here. You can, so the sixth part is x minus root 2 whole square minus root 2 x plus 1 equals 0. Now applying the identity over here, a minus b whole square. So this is x square minus 2 twice of ab, 2 into x into root 2, and then plus root 2 square minus, and this will be root 2x, and this will be minus root 2 equals 0. So now solving this, over here you get x square minus this will be 2 root 2x, sorry not root x, is 2 root 2x actually. This is root 2 x and then plus 2, because under root of 2 and then square will be 2, minus root 2x minus root 2 equals 0. So now we can write it like x square. Now see, this is minus 2 root 2x, this is minus root 2x, so minus 3 root 2x, and then plus 2 minus root 2. So this is a constant term. This is the constant term 2 minus root 2. Now comparing it with the equation ax square plus bx plus c equals 0, we get a equals, comparing it, we get a equals 1, b equals minus 3 root 2, and c as 2 minus root 2. Now applying the formula of discriminant, which is b square minus 4ac, d is b square minus 4ac, and then writing this is minus 3 root 2 whole square minus 4, a is 1, and this is actually 2 minus root 2. Now see, minus 3 whole square will be 9, and root 2 square will be 2. So 9 into 2, this will be 18. So minus 3 square is 9 into 2, writing over 18, minus, now expanding the bracket, this is 8, and this is minus plus 4 root 2. So 18 minus 8 is actually 10. This is discriminant. 18 minus 8 is 10 plus 4 root 2. We can clearly see that this term is actually greater than 0. So over here discriminant is greater than 0. So thus it has real and distinct root. Distinct, yeah, same thing, distinct real roots. Or you can also write 2 distinct real roots. On to the next part, which is question 7. Oh, sorry, again, which is question 7. The question 7 states that under root 2 x square minus 3 by root 2x plus 1 by root 2 equals 0. So writing it over here, the seventh part. So this is root 2x square minus 3 by root 2x x plus 1 by root 2 equals 0. Now see, we can directly compare it with ax square plus bx plus c equals 0. So what is a? A is root 2. B is minus 3 by root 2. And c is 1 by root 2. Now applying the formula d equals b square minus 4ac. d equals b square minus 4ac. See, what will be b square? B square will be minus 3 by root 2 whole square minus 4 into root 2 into 1 by root 2. So actually this becomes positive. This will become 9 and root 2 whole square will be 2 only. So 9 by 2. 9 by 2. We can see root 2 will get cancelled. So 9 by 2 minus 4. Now taking the LCM. This will be 2 only. So writing here at 1. So this is 9 minus this goes 2 times 8, which is 1 by 2, which is greater than 0. So hence discriminant over here is again greater than 0. That means it has 2 distinct real roots. So this will have 2 distinct real roots. Now on to our next part. So we can see the question here. Here is the question. Our next part is actually the 8th part. So 8th part given is as x 1 minus x minus 2 equals 0. So writing the 8th part. Yeah. 8th part is x 1 minus x minus 2 equals 0. Now see, this is x solving. This is x minus x square minus 2 equal to 0. Now rearranging, writing the x square term first and taking the minus sign common. So you can write like this: x square minus x plus 2 equals 0. Comparing it with the equation ax square, the general equation ax square plus bx plus c equals 0. A will be 1, b will be minus 1 and c will be 2. So applying the formula, d is b square minus 4ac, b square minus 4ac. So b is what? This is minus 1 whole square minus 4 into 1 into 2. So that becomes 1 minus 4 into 2 is 8, which is minus 7. So this is less than 0, which is less than 0, hence no real roots, or you can say the roots are imaginary. No real roots, or the roots are imaginary. So on to our next part. Our next part is will be the 9th part. So let's see 9. So this is given x minus 1, x plus 2 equals 0. So now writing the 9th part. So 9th part is x minus 1, x plus 2 equals 0. Now this solving this becomes x square minus 2x, x square minus 2x, then this minus 1 minus x plus 2 equals 0. So this will be x square minus 3x plus 4 equals 0. So sorry, I think I have made a mistake over here. I think I have written the question wrong. This is actually x plus 2. Yeah, this was actually x plus 2. So x square, this will be plus 2x, and then plus 2x, this will be plus x plus 4. Will this be the answer? No. Remove this also. That's not correct. Actually, this will be minus 2. Minus 2 will get cancelled. So you will be left with x square plus x equals 0. So 2x minus x is x. So see, the constant term is 0. So we can write x square plus x plus 0. And then comparing it with ax square plus bx plus c equals to 1, we get a equals to 1, b is 1, c is 0. Applying the formula, d equals b square minus 4ac. That is 1 square. D is b square minus 4ac. So that will be 1 square minus 4 into 1 into 0. Basically this part will be 0. We are left with 1, but still 1 is greater than 0, hence d is greater than 0. That means this will have real and distinct roots. Now moving to our last part, which is the 10th part. So the 10th part is x plus 1, x minus 2 plus x equals 0. So writing the 10th part over here. So this is x plus 1, x minus 2 plus x equals 0. So now solving this. This is x square minus 2x plus x minus 2 plus x equals 0. So now we see that the x and x is 2x, minus 2x and plus 2x gets cancelled. So you have x square minus 2 equals 0. So we see that the coefficient of x is 0. So we can write this as x square plus 0 into x minus 2 equals 0. Now comparing it with ax square plus bx plus c equals 0. A is 1, b is 0, c is minus 2. Applying the formula, d is b square minus 4ac. So that will be 0 square minus 4 into 1 into minus 2. So that is 0 only, but minus 4 into minus 2 will be plus 8. So this is greater than 0, hence it has two distinct real roots. So this has two distinct real roots. Real and distinct roots. Okay. Now moving on to the next question. Here is the question 2. So this is the question 2. Write whether the following statements are true or false. Justify your answer. So first, every quadratic equation has exactly one root. So our first is actually this will be false. Since the quadratic equation, now this is actually false because what quadratic equation has only two roots. So that's what we will write over here to justify our answer, because every quadratic equation has two and only two roots. Okay. Now the second part. Every quadratic equation has at least one real root. So this is also false. Now to verify this, we can take an example in which the equation, you suppose they are saying one real root, but if you consider the equation as x square plus 9 equals 0, you see it doesn't have any real roots. Has no real roots. So x square plus 9 equals 0, so this will have no real roots. That's correct. Now coming on to the third part. Every quadratic equation has at least two roots. So third We see third is also false. Since a quadratic equation has two and only two roots. It's not about at least. They has only two and only two roots. Since the quadratic equation has only two roots and only two roots. Yeah. Now coming on to the next one, fourth one. Every quadratic equation has at most two roots. Now fourth part is true. Now the fourth part we write true because every quadratic polynomial has at most two roots. That's correct. So writing the fourth part as true. Every quadratic polynomial has at most two roots. Yeah. Now the fifth part. If the coefficient of x square and the constant term of quadratic equation have opposite signs, then the quadratic equation has real roots. So see, this is actually true. So writing the fifth part over here. So fifth part is actually true. Now see, the thing is that they are saying the coefficient of x square, that is a. Now if you write the equation as ax square plus bx plus c, they are saying coefficient of x square in the quadratic equation has opposite sign. So that means if you write a and c, opposite sign means that will be less than 0. Yes. And what about the discriminant? Now we know that the discriminant is b square minus 4ac. b square minus 4ac. Now when ac is negative, that means this will become positive. This thing will become positive. So that will be b square plus 4ac. They both will be positive, hence this will be greater than 0. Hence this is true. So they will have real roots. So this thing is true. Now the last part, sixth part. If the coefficient of x square and the constant term have same sign, and if the coefficient of x term is 0, then the quadratic equation has no real roots. Again this will be true. As we can see, ax square plus bx plus c equals 0. They are saying coefficient of x square, which is a, and the constant term c. When they will have the same sign, that means ac is greater than 0. AC will be positive when there is the same sign. And discriminant, we know that b square minus 4ac. Now see, the x term is 0. They have given, so this is 0 minus 4ac. Now being ac being positive, so minus 4ac total value will be negative. Hence this will be less than 0. So this will have no real roots. Hence this statement is true. Now question number 3. So question 3 is a quadratic equation with integral coefficient has integral roots. Justify your answer. So the coefficient should be integral and the root should be integral. So the answer is no. Because see, the answer is no because see, if we take a quadratic equation which is 3x square minus 7x plus 2. So we can see the coefficient all are integrals. So this is for example, so all are integral coefficient. Now let's do the factorization or the middle term splitting. So that will be 3x square minus 7x, you can write minus 6x minus x plus 2. So we can take 3x common. So over is x minus 2 minus 1 common. So x minus 2. So you can take x minus 2 common then. So this will be 3x minus 1. Actually this should be equal to 0. So that means x minus 2 equal to 0. X equals to 2 or 3x minus 1 equals 0. So this implies 3x equals 1, x equals 1 by 3. So as we can see, the coefficient is integral, but you can see the roots. One is integral root, but the other one is not integral. It is a fraction. So hence our answer is no for this. Now question 4 is, does there exist a quadratic equation whose coefficients are rational but both of its roots are irrational? Justify your answer. So the answer is yes. We can see that there is a quadratic equation. So consider the quadratic equation 2x square. We can take 2x square plus 5x minus 4. So you see that the coefficients are rational. Now when we solve it, so let's solve it by the by the quadratic formula. In the quadratic formula, we know that a is 2, b is 5, c is minus 4. So x will be minus 5 plus minus under root of 5 square, which is 25, minus 4 into 2 into minus 4 whole upon 2 into 2, that is 4. So now solving this, minus 5 plus minus, this is actually just becomes actually plus 32 because of this minus sign. So 25 plus 32 is actually under root 57 upon 4. So here the roots are, as you can see, the roots will be minus 5 plus roots 57 by 4, and the other root is minus 5 minus root 57 by 4. So we can see that the roots are irrational. So here we have an example where the coefficients are integrals, and we can see that the roots are irrational. Now next question is question 5. So the question 5 is, does there exist a quadratic equation whose coefficients are all distinct irrational but both the roots are rational? So yes, there exists. So we can take an example. Now consider an example. Take a quadratic equation root 3x square minus 7 root 3x plus 12 root 3 minus 7 root 3x plus 12 root 3. Now see, factorizing, you're finding in the roots by the quadratic formula. A is root 3, b is minus 7 root 3, and c is 12 root 3. So comparing it with the equation, ax square plus bx plus c equal to 0, we see that a is root 3, b is minus 7 root 3, and c is 12 root 3. Now applying the quadratic formula to get the roots. So over here x will be x, we can write minus b. So minus b plus minus under root of b square minus 4ac, that's the formula actually, minus 4ac upon 2a. Now substituting these values, so minus b will be 7 root 3 because that's minus, plus minus under root of b square is again minus 7 root 3 whole square, minus 4 into root 3 into root 3 into 12 root 3. So writing here, into again 12 root 3 divided by 2a, a is root 3, so that will be 2 root 3. Now solving this, so this will be writing here 7 root 3. So writing over here 7 root 3 plus minus whole under root. So see, minus 7 into root 3 whole square, so that is 49 into 3. 49 into 3 is actually 49 into 3 you do is, that is actually 147, because 7 square is 49, root 3 will be 3. 49 into 3 is 147 minus, see, 12 into 4 is 48, and then root 3 3. So 48 into 3 is 144. So this will be 144. You can write here 144 whole upon 2 root 3. Now again, see, 147 minus 144 is 3. So this will be 7 root 3 plus minus, so this over here will be root 3. 147 minus 144 root 3 upon 2 root 3. Now what we can do is that we can take root 3 common from the numerator. So this will be 7, and what is left is plus minus 1 upon 2 root 3. Because if we take root 3 common, so upon 2 root 3, now you can cancel root 3. So now roots will be 7 plus 1 by 2. That is 8 by 2, which is 4. Similarly 7 minus 1 by 2, which is 6 by 3. 6 by 2, that is 3. 6 by 2, that is 3. So you can see the roots are 4 and 3. So hence this is an equation in which all the coefficients were irrational but the roots were rational. So hence it exists. You can clearly see these root 3, minus 7 root 3, 12 root 3, they all are irrational. But as you can see, roots, which is 3 and 4, which are rational or integers. Now, question number 6. Coming to question 6. Is 0.2 a root of equation x square minus 0.4 equals 0? Justify your answer. Now see, we know that when fx equal to ax square plus bx plus c, and if a is the root of this equation, so that means if a is the root of this above equation, so that means fa equals 0. So write fa equals 0. Now the given equation fx is actually, this fx is, fx equals, this is x square minus 0.4. Now what will be a? A is actually 0.2, so writing f of a as 0.2, so this will be 0.2 whole square minus 0.4. So actually this is 0. No. I think there is a mistake. There is a mistake. It's 0.2 whole square is not 0.4. It's actually 0.04. So this, sorry for this, 0 point whole square. This is 0.04 minus 0.4, which is actually not 0. So whatever is the answer is not 0. So 0.2 is not a root of this equation. Is not a root of this equation. Now, coming to question number 7. If b equal to 0, which is given, c is less than 0. Is it true that the roots of x square plus bx plus c equal to 0 are numerically equal and opposite in sign? Justify your answer. Now see, it is given that b equals to 0 and c is less than 0. And there is a quadratic equation x square plus bx plus c equal to 0. Now substituting b equal to 0 in this, so we have x square equals, not equals, first of all write x square, this becomes 0 plus c equals 0. Now see, x square, this will be, if you take c to that side, this will be minus c. But it is given that, what is c? C is negative. So minus of minus c actually will become positive. So this will become positive. So we can write x square as c. So this x will be under root of plus minus c. Plus minus under root c. So hence we can see that it has the equal answer but is of opposite sign. One is plus root c, other is minus root c. So our answer is yes.